Our new guy crashed it the other day. I ran the first one through, and I didn't take it off an optional stop. And then the boring bar came in to do that little ID chamfer and just plowed right into that solid stock.
I hit my tailstock yesterday. It came down and hit my tailstock and then tried to do the Z move. I didn't catch it. I hit cycle start and it started moving. I'm like, why is it going that way?
Whenever somebody crashes a machine, does anybody ever fly off the handle, or is it usually like a teaching moment? How's that handled? Go in the bathroom and scream at yourself in the mirror?
Or throw wrenches through the drywall.
Throw a wrench at yourself?
Throw a wrench at the wall. I think it probably is going to depend on what happened and how it crashed.
You have to weigh, like, is this a one-time thing, or is this the second time in a week that this, something's happened?
This is episode 10. We're going to do a giveaway.
We are giving away a Lixie dead blow hammer, a Machinist Calculator Pro, and we're going to be giving away just some swag. So, all kinds of goodies for you guys. Hello, everyone, and welcome to the Impractical Machinists podcast. My name is Patrick. You can find me on Instagram as @JobShopperTN.
I'm Cameron from Machining is Cool.
I'm Bradley with Marvel Machining.
On this episode, we're just winging it, so buckle up.
We're gonna continue talking about them damn lathes.
Why not? Oh boy.
What were you just talking about, Pat?
You said 20 or something.
Yeah, our manual guy didn't have a whole lot of work to do, and we had some 2 orders of 20 parts that were, they're lathe parts, and not really something you should be doing on a manual lathe if you want to make any money. I think one was basically a tube, I think, with a hole through the side of it, just a steel tube. They really should have bought DOM tubing for it, because it's like 2-inch OD, 1.25 or 260 ID. Could have bought tubing for it easily, but for some reason we ended up with 2-inch solid. So it's kind of funny. I got to show him how wonderful an indexable drill is. They don't get to use that very often. They're still using high-speed steel twist drills, and he was fully planning on doing like a 1/2-inch pilot and then a 1.1/8 twist drill, and then boring it out, the rest of the way with the bar. And I was like, I might have something better. So I went and get the 1.25 indexable drill we have, and I was a little nervous about it because never really used that in a manual lathe before, and it's a little long. It's like I don't remember if it's a 6 times or 8 times D drill, so it's kind of long. But I let him have it and told him, one thing I like to do with him, because obviously he's a manual guy, so he's not used to running stuff fast. He'll ask me, I'll hand him a tool to try out on something weird, and he'll ask me, what RPM should I run that at? I'll be like, well, how much you got? But I told him, right. I told him, start, I don't know, 600, 800, something like that. So he put it on the big manual lathe we have, put it on 666 RPM. So that's nice.
Nice.
And it just drilled like a dream. Now it drilled a little undersized.
0.6 a rev.
Yeah, that's probably his feed rate. It did great. So he actually kind of enjoyed doing that, even though he had to make 20 of these things. He still had to bore them out because it drilled like 1.230, oddly enough. But it worked pretty well. And then the other set, yeah, I know. I've always found like in a CNC lathe, intended, I always find you got to offset X on indexable drills like 10 or 20 thousandths. One, for them to drill better. If I indicate them to center line, they sound a little crunchy. But if you offset them like 10 or 20 thousandths, either in the program or in the offset, I don't know, they seem to work better that way.
See, we don't have to worry about that because our lathe is always out of alignment.
Same.
Our Johnford lathe. That thing's, well, the whole turret is just, there's nothing like rigidly locking it in place. Like there's no mechanical interlock that keeps it from twisting in the X direction. it's just 4 bolts on the bottom of the turret, 4 bolts on the top of the turret, attaching it to the X-axis. And so I think over time it just turns a little bit just from all the force.
Mm-hmm.
And then we'll crash it and the spindle will be out a little bit, but we just roll with it until it gets bad enough and then we'll realign it.
You just got to say no to turning.
Right? Yeah.
Right.
Our new guy crashed it the other day.
Oh.
Yeah, we're making some brass slingers, and Op1 was already done on them, and he was doing Op2. Op2 is just roughing the back off and then facing it, and then boring bar comes in and puts a little chamfer on the ID. And I ran the first one through, and I didn't take it off an optional stop, and so he ran the first part. It roughed the whole back of it off. It was on optional stop, and so he opened the door, saw the part, looked like a finished part, but just had like a rough texture on it. And so he took it out. It's like, that's kind of weird. I wonder what's up with that. Put the new one in, pressed go, and then the boring bar came in to do that little ID chamfer and just plowed right into that solid stock. There's like, 3/8 of an inch right there of just brass. And so it wasn't a terrible crash. Like nothing's permanently broke. The only thing permanently broke is a clamp for the boring bar and the little riser for the insert, whatever you call those little, what I'm talking about?
Yeah, the insert seat.
I forget what the actual term is for them.
Mm-hmm.
Yeah. So anyways, broke that and the little clamp. So ordered a new boring bar just to have a spare and some extra parts for it.
Yeah.
And then, Sam was realigning it and he's like, yeah, it was out like if you sweep the face of the turret in X, like jog it up in X across 4 inches, it was out like 50 thousandths.
Holy moly.
So it turned a good bit.
Right.
Yeah. I hit my tailstock yesterday.
Really?
Ooh. Yeah. Well, I mean, everybody knows I'm not big into turning, so I don't program on the machine. I use my software, and I haven't gone through and messed with any default settings, and it's my fault because I don't pay much attention to it. I kind of just hope for the best. But it was set to move X before Z. So it came down and hit my tailstock and then tried to do the Z move.
Yeah.
And I didn't catch it. I hit cycle start and it started moving. I'm like, why is it going that way? And then it just hit the tailstock and stopped.
Yep.
Oof. Yeah. I got to watch that because.
Which I think I probably wouldn't mind turning as much if I actually went through and changed some of the parameters. And that's what kind of drives me nuts programming it. It does a lot of funny stuff that I just don't know because I don't have the experience doing it. And it's like every time I post it, I'm like, that doesn't seem right. Why is it doing that? Then I go back through and find that stupid parameter and stop it.
Mm-hmm.
Yeah. It's kind of a, like you don't want to turn anyways. And when you are doing it, you just want to get it over with.
Yep.
You don't want to stop and take the time to fix all the little things. But then all the little things are really what's making it shitty for you. So it's just a vicious cycle.
Yep. I mean, I can count on probably one hand how many times I've programmed and set up my turn-in center.
Yeah.
So it's like, and every time I do it, I try to remember, okay, I'm going to save that setting. Or I have saved a couple of them, but then I forget that I have them saved. Because it's probably once every 6 months I even program something.
Yeah. Mm-hmm. Do you have a turning template set up?
No.
Or, well, I don't know how you, because you don't use, well, I guess you do have templates, don't you?
You kind of templates, defaults.
Feature recognition with defaults set. I don't know if you've done that with turning.
No, I haven't, and that's part of the issue. And another thing that, and I don't know if all software does it, but what mine does is it's default into like a work in progress stock. So, and movements. So if it roughs out something and the tools down here at Z, wherever it is, it's the next operation is seeing where that is. So it's starting there and coming back. It's linking the rapids together. And sometimes I'll post out a finish move and it'll try to go somewhere funny on the part and then it'll come back. And I just never catch it because I don't ever simulate it either. I just run it.
Yeah.
You're crazy.
Yeah, turning sucks.
Golly, Brad. Yeah. But no, I get it. I mean,
yeah,
it's pretty rare that I have to use a tailstock on our lathes, but I'm always having to watch, like, making sure Z moves first, make sure the tour tracks are the same way, come up, come up and then out in Z. Because, it's so easy to crash it that way. And Cam's story reminded me of I'm going to say probably the worst crash that I've seen us do as far as like a tooling aspect, like breaking, ruining tooling. And it's exactly like what happened to your new guy. A guy was running a part as like a 7-inch slug on our DS30, and we'd only had it for like 6 months at that point. And I don't know how he just got confused. He took the part out. Instead of flipping it, he loaded a new piece of stock. And I think the next step was to bore the other side. Like it was drilled through and just needed cleaned up or something. Well, we were using an 1.25 inch carbide shank boring bar. And it came in and rammed home, and it just obliterated it. I don't even know what it did to the machine. I don't think it really messed the machine up that bad, which is amazing for a Haas. But
I would
that
think
bar
with
was like $3,000.
carbide, it just shatter.
Yeah, that's probably what happened. That may have been what saved it. Because if it was a steel bar, it would have
Right.
bent and got ugly.
Right.
But yeah,
Like ours did.
Right. Exactly. That was a bad day for that poor young lad, because he was co-oping from the tech school. And so, he'd only been with us like a few weeks,
Oh, man.
and then that happened. I'm pretty sure he really wanted to just like walk out the door and not come back. But we're a little bit more patient than that.
I've been in that same scenario where you just want to leave and never come back again. Well, I want to ask another question about how you handle like the people aspect of crashing, but
Sure.
also we were machining some copper parts, and they're like 1/4 inch thick or 3/8 thick, a quarter. It's literally just profile, drilling holes, and some slots and chamfering, and that's it. But for some reason, we needed to change. I don't remember exactly what I did, but we needed to change what we were doing, or like do an operation on another part real quick. And I was like, oh, I'll just hand jam whatever it is we needed to do. Honestly, I don't remember exactly what I was doing, but for some reason, I decided I was going to hand jam and change the tool number in the program, but I forgot to change the H number for my height offset. So it went to take I don't remember what size drill it was, but take a drill and go drill, whatever this hole was in this copper, and had the wrong H number assigned to it. And so it just rapided right through the copper, jammed the drill right into it, exploded. It was a high-speed steel drill. The whole drill just exploded, shattered the window on the machine. And I think I'd been there for a few months, maybe, if that. But yeah, that was.
Do your machines not match H and T numbers?
Not if you're hand jamming.
Oh.
Not so. Yeah, there's you've got your like M6 T11, we'll call it tool 11, but I changed that to like tool 14, right? Well, later in the program, there's still G43 H11. I didn't change that H number.
So on my mills, if my H and my T aren't matched up, it'll alarm out.
Oh, really?
So if it pulls up tool 11 and then it sees H15, it'll alarm out and say we're on tool whatever.
Now, I wonder if that's something you can turn on and off.
Yeah, I know mine's a parameter. I've always left it on.
Yeah,
I've used that to my benefit before, trying to match things. Like you say, you need a blend, or whatever. You get different depths that aren't working out the way you want them to, and you can use a different. Like if it's tool 11, I'll use like H111.
Yep.
Or same thing with my diameter offset. You're doing like a boss and a bore, and I'll just do a D111 and then have D11 for one, D111 for the other.
Yeah, I have it. I have that set up in my software that I can change it for an operation too. Sometimes if I need to have another value.
Yeah, I can do that as well, and we'll occasionally do that. Something I've been doing, which has been pretty nice. So the way we normally will dial in like your first part. So you've got a fit that's +1 minus nothing, and that finishing tool, finishes some walls and some floors, and then it goes in and finishes that fit, right? So the way we normally do this is your first part, have your tool offset out 1,000th on its diameter or on its radius. You run the whole part, measure that fit, do the math, your target diameter minus your measured diameter divided by 2, and then apply that to your tool offset. Then rerun that tool. So something I've started doing recently is I'll do in my CAM software, I'll make all the tool path before that tool and after that tool optional. So then after your first time running it through, you can measure that fit, make your diameter offset, turn optional block skip on, and it'll just skip all the way down to that tool, run just the finish pass, and then at the end it brings the table forward, homes everything out. And yeah, I guess you just got to remember to turn it off for the next part.
Right.
That's something I started doing recently, which has been pretty helpful.
Yeah.
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 Does Fanuc not have a good like restart in the middle of a program function?
No. I mean, it's there, but it's not like you have to set your it depends on where you start. So you have to know where you need to go back to in the program, and then you also need to go to MDI, set your spindle RPM and direction, and I think you may have to set your tool, like if you have active tool length turned on, you have to turn that on. So like your G43 H number, and then you can leave the spindle running, go back into the program, restart stuff, go to the little line number that you need, and then start there, and then pick it back up. And yeah, so it's not very convenient at all.
Yeah, that's one thing I guess Haas does.
I've only tried Haas's once, and it. I've only tried it once, and it did some goofy stuff, and I just stopped it.
Yeah.
The only the times I have problems with Haas's program restart function is if we're doing probing or if we've got any like macro junk going on, which is pretty seldom. But usually, from SolidCam, I mean, all my tool paths will post out with a header, so they'll be in parentheses, and a lot of times it won't make much sense. It'll just be like F-contour 4 or something like that. But a lot of times, what the operators will do is just search for the D number, because we use comp at the machine. Like if it's D5, they'll just search for D5, go up about 3 lines, and that's the header for that tool path. And then they just hit cycle start, and it reads back through the entirety of the program from start all the way down to wherever you start at. And that way it picks up your T number, H number, speed, feed, all that garbage. And what it'll do is it'll go to Z home slowly and move to the last XY position, slowly come down to the last Z position, and then get to working. It can do some weird things. Like if one tool path is on the left end of the part and the other's on the right, it could do kind of weird stuff, but it usually works good.
I think that's what happened when I did it. It came down like you said, and it started coming down, but then I don't remember if it wanted to go back up and over to the right tool path or if it was going to start going through the part, so I just stopped it.
Yeah. I think they want you to position it relatively close to where it needs to start before you do that.
Yeah. I always just post it back out where I did that operation.
For me,
like you said, I got the parentheses of each operation, so I know which one I need to post out.
Yeah. For me, it's a matter of just what's going to be the safest option.
Yep.
We could figure out, and there may be a better way to restart the program. There's something I don't know about Fanuc, or Fanuc, whatever. But for me, I'd rather just post it back out and not have to worry about the guys on the floor,
sure,
missing something or myself missing something. And then next thing you know, you're plowing through the side of your part or something weird.
Yep.
Process reliability is more so what I'm after. But I would like to know if there's a better way to do that on the Fanucs. I'm sure somebody knows better than I do about the program restart, but that's really kind of one of my pet peeves. Like it's I'm pretty sure on like a 2005 Herco, they have that option. Like just go stop for a second. Oh, go back to where I stopped last. And like this stuff's been figured out forever, but for some reason they make it like trying to decipher hieroglyphics on a Fanuc.
Yeah. I have to ask a friend of mine that he's got two Fanuc machines. And he showed me that function one time, and it wasn't as hard as what you're describing. So I'll have to ask him and see if he can write that out for me.
Like I said, I mean, I might be ignorant to it. Who knows? Oh, but so crashes. Whenever somebody crashes a machine at your shop, does anybody ever fly off the handle, or is it usually like a teaching moment? How's that handled? And like Brad, I know you're working by yourself, so I don't know if you
just fire
go in the bathroom and scream at yourself in the mirror, but
or throw wrenches through the drywall.
Throw a wrench at yourself.
Throw a wrench at the wall.
Yeah.
Oh man, I've been there. Well, what we usually do.
I mean, Ken, I think it probably is going to depend on what happened and how it crashed.
Yeah.
User error, program.
Yeah.
Right.
And if it's been a common problem or not. Yeah. If you have to weigh like, is this a one-time thing, or is this the second time in a week that this something's happened? Well, my story earlier about that carbide boring bar. Now look, I mean, you got potential damage to the machine, which fortunately didn't really happen. But you're out. It cost us, like I said, I think $3,000 to replace that boring bar. And the way that we handled it was basically the general manager lives right across this road from the shop, so he'd come down, and he might have actually been there at the time. And he basically tried to tell the kid, this really sucks, but it happens. I want you to go home.
Yeah.
Come back tomorrow, and we'll try it again. We'll fix it and move on. And I think that's the best thing you can do, especially to somebody that's just getting started, because, I mean, most machine shops are not going to give people a thorough training. And sometimes it just comes down to being ignorant, being distracted, making a mistake. And, like if we would have fired him, right, if we would have fired him, that young, I don't know what he's up to now, because he left after about a year or so to go do something else. But, that would have probably ruined him from being in the trade. It would have given him the impression of like, man, you make one screw up, which, mind you, that's an awfully big screw up. $3,000, that's nothing to sneeze at. But, it wouldn't have made a good, impression for him. And even if you're experienced, I mean, at the end of the day, we just have to accept that things happen. And if you have an employee that is normally a good, conscientious employee, they do a good job, good work, they have good attendance, whatever, and they happen to goof up and scrap a part or have a minor crash, not something that turns a machine into a pretzel. Just that's kind of the risk that you take having a machine shop.
Right. Kind of just the cost of doing business. And that's kind of the way we look at it. We have the same approach as you guys do. It sounds like whenever, that our newer guy crashed the lathe the other day, nobody got pissed off and flew off the handle. And I think that's what he was expecting. I think he was expecting me to be angry about it. But I tell people, especially when they're new, I tell them all the time, like, hey, just so you know, you're going to screw stuff up. You're going to break stuff. You're going to scrap parts. And also, just so you know, I'm going to do it too. Mm-hmm. Sam's going to do it. He's been machining 30 years. We're all going to screw stuff up. There's too many factors here. No matter what, something is going to get screwed up. Almost weekly, something gets screwed up. I mean, it's just the way it is.
Yeah.
And you try to learn the best you can from it and keep it from happening again. And part of it comes down to the individual, being able to learn a lesson from whatever that situation was. Like, for him, like, whenever we talked about it afterwards, he was like, yeah, I took it out. Or he's like, I looked at it and I was like, that looks kind of weird. After the roughing cycle, before the finishing cycle, he's like, it looks kind of weird. I didn't really know what was up with it, but then I was like, I'll just run another one and see if it does it again. And I was like, yeah, that right there. Like, remember that thought that you had? Anytime you ever have that thought, stop and don't run anything else, because it's bitten me so many times. I'll look at something and be like, wonder what's up with that. It's kind of weird. I'm like, I don't know, maybe it'll sort itself out. Or I'll just run another one and see if I can figure it out on the next one. Right. And it's like almost every time I had that little internal thought, that internal dialogue, something gets screwed up. And so I wanted to try to get that point across to him. But
I think another thing is to get across to employees or yourself is accident happens, crashes happen. It's going to happen. Don't let it ruin the rest of your day.
Oh, 100%.
I mean, even like yesterday, when I stepped on the pedal and my part fell out of the chuck, I could have got pissed off, and I actually thought about just shutting everything off. But I don't know if I just walked around the shop and I sat down. I might have read something online and just I put it behind me, and then I started fresh. I put it in the other machine and I just started over, and I got the part done.
Yeah.
I mean, if I would have been upset about that, I could have ruined it.
Yeah. No.
Yeah. Oh,
no,
yeah.
I mean, I will say some days you just need to stop.
Yep.
There's definitely been days like that where I'm like, I just need to stop freaking trying.
Yep.
We just need to just, put a pin in it today and then come back tomorrow and with a fresh mind.
Mm-hmm.
But no, you're right.
Dwell on it.
You screw something up, you can't let it eat at you all day. I mean, it needs to affect you to a degree so that you'll remember not to do it again.
Yeah.
Like it should hurt a little bit. Like pain retains. You need to learn that lesson, but also just don't eat shit the rest of the day because of it.
Yep. Mm-hmm. How do I prevent myself from stepping on that pedal again?
What you need to do is have a cover over the pedal anytime you're running. You 3D print you a little cover to go over it.
Well,
so you have to lift
box.
it. Well, no, in front of the box, you need something where your toe can't go in unless you lift that thing.
What we usually do is
if that thing's running and I step on it, will it open?
It shouldn't.
No, it shouldn't. No,
I don't know. I've never tried.
I'm gonna try it today.
What we usually do, Brad, is we'll take that pedal, those pedal box, and slide it over a little bit to where, like, if you're standing at the machine with the door open, the pedals aren't right there. You kind of have to put your leg off to the side a little bit to actually actuate it. And, we might move it if we're doing like a fast cycle flip job or something, but kind of helps keep that from happening.
I like that. I kind of have the same approach whenever I'm making parts that are on a fixture in a vise. And so like you're bolting parts down to a little fixture or something, I'll hide the vise handle from myself because I get in such a habit of grabbing the vise handle and opening up the vise to change parts out. I'll do that with my fixture, and then I'm like, son of a bitch. Now I got to reprobe this and whatever. So I'll just take it and hide it all together so I can't accidentally do it.
My pedal is off to the left, and I'm right-handed, so I usually kind of go with my right foot awkwardly because it's to the left. So I don't know if my foot just kicked it or what happened. But like I said, I grabbed the door and I heard the clunk, and my part was laying down at the auger, and I was like, God damn it.
I've definitely done the same thing.
I don't even remember like stepping on it. I must have just kicked it just right to where it gave it enough of a press to open the chuck.
Oh, I've straight up like just not paying attention. My mind is just somewhere else, and I'm just like, all right, let's swap this part out, but it's not even ready to be swapped out. And you get in the routine of things.
Yep.
And you're not even thinking, like I said, your mind's somewhere else, and then you're just going through the numbers, and it drops, and you're like, oh, fuck.
Right.
Why did I do that?
Well,
I've done it in the mill, like you were saying, where you gotta hide the vise handle. I've had fixtures in the vices where I would just be taking off a clamp or something, but I've grabbed the vise handle and I've opened it up, and then my fixture's loose, and I'm like, oh, fuck, here we go. So I throw it in a drawer too.
Yeah.
Yeah. I will say,
a good little nugget for you guys.
What year is your SL20, Brad? Roughly.
2003.
Okay, so to me, we've got two lathes from around that era. I think at 2000 and 2001. The Haas pedals from back then are pretty sensitive too. The newer ones aren't that bad. Like our DS30, it's a little bit more firm to where I don't think you could like tap it and it would actuate. But so upgrade your lathe.
Not happening. I'm trying to downgrade that.
I was going to say your upgrade to a lathe is another mill. I had a little.
I've been getting a lot of turning work though lately.
I've seen that on your page. Yeah, it's very funny. There's actually a story on the subject of like crashes that I wanted to relate. I heard this. Gosh, I probably hadn't been working here 3 months. The programmer that we had at the time, he spent some amount of time working at a place down in Chattanooga, which was a very unique shop. They made like huge power turbines and things like that. So they had lathes in there that were like 30, 40 foot swings, massive machines. And I think the company was based in maybe France or Germany. So, they're making these turbines and things like that. These are literally multi-million-dollar parts. I think he said at the time, like one turbine might have been $40 million. It took them months and months to make. So, and they're turbines for hydroelectric dams and things like that. So they're going into huge government projects that are very time sensitive, to where if they don't deliver on time, they're getting fined hundreds of thousands of dollars a day because they didn't hit their date like they should. So they get done machining this, and they put the fan blades on, and it goes through a final inspection process on this huge CMM. And this guy's checking the blades out, and their CMM tech does something, and it makes it ram the head through the turbine. Jacks up the CMM and jacks up the turbine, and makes it to where they've got to, take a large portion of the blades off, make new blades, re-weld them back on, remachine it, rebalance it, re-inspect it. It's bad. So what do? I mean, the American thought process, honestly, would probably be, this guy just cost us a ton of money, and the only thing we can legally do to him is fire him. I wish we could do more. Or maybe that's like the boomer mentality. I don't know. What they did is they were like, well, our process was insufficient. What failure on the part of the company occurred to let this happen? He kept his job.
Mm-hmm.
I mean, I'm sure he probably felt bad. I mean, he should have, but they just chalked it up to, well, things happen, and really we need to find a way to fix our process to keep this from happening again. That's like a huge, super high level version of that.
That way of thinking is what I try to implement.
Mm-hmm. Me too.
If we're having, especially if I notice something happening multiple times, the same mistake happening multiple times, or the same thing is getting missed multiple times, it's like, okay, it's not just the one employee. It's something in our process that is allowing this to happen. What do we need to change? Whether it's something simple, or maybe we just need to talk about it. Whatever. Do we need to implement something new? Whatever it is, there's somehow we as a company are allowing them to fail, or not setting them up for success, because we don't have certain processes in place or certain procedures. And so that's something that I've been, and I mean, it's not necessarily just one employee screwing things up. It's like I said, like, we don't have an ERP system, and not that every company needs an ERP, or not that that's the answer to everything, but we went from having paper POs with prints and Sam just tracking everything in his head, to adding people into the mix, like me running things, me running the CNC shop, and I don't know what he's ordered, what he hasn't ordered, or he ordered it and it was supposed to be in, but it hasn't come in yet, and we need to talk to the our material supplier and figure out why they haven't sent it to us yet, or the material arrived and we got the wrong stuff, or whatever. There's certain processes that, or maybe he planned on making this from a solid, even though it's weldment, but the print shows that it needs to be a weldment, so I'm preparing to make a weldment. But he's already ordered, 3-inch thick material to just machine it out. So there's all those different things that, we're not even communicating, and there's stuff getting missed all the time. Or, a PO gets set down somewhere and then you forget about it because it's sitting over here by something else and you don't even see it. So a bunch of little stuff like that. So, I mean, that's on like a company level, that those things are happening, because I'm missing stuff, he's missing stuff, the guys are missing stuff, all because we don't have a good flow or a good throughput process for our work. And so getting mad at one person for screwing that sort of thing up is not the way to go.
Right.
You have to kind of take a step back and detach from it and look at it and see what we can change as a whole to make this better and keep it from happening again, which is what we've been doing. We just started with an ERP. I started the implementation process of an ERP system. I'm working with the company right now to get it going, but that should help a lot. And another one is inspection. We've had we've never had a full inspection program. It's always just been machinists working for us, and the rule is you make the parts, you make sure they're good, right? Make sure
Sure.
they match the print. You inspect your own work. But as we've hired, well, I can't just say as we've hired new guys because I've definitely missed stuff or forgotten to inspect something or whatever. I think we've all done it, but it's most prominent, or the mess ups or the missed things are most prominent with new guys just because they're inexperienced and they haven't been machining for 5, 10, 20 years. They're missing features, inspecting stuff incorrectly and thinking it's within tolerance, but it's really not. And it's getting sent out the door, and then we're getting rejections. So, and it's not a ton of stuff. And it's not like we're getting rejections every day for things, but it's still happening. So now I'm working on implementing an actual inspection process, getting auto bubbling on the prints. And so everything's going to be laid out nice for you. And you can just go right down the list and inspect it all. Probably going to do tablets where you can just type it all in on a tablet. We'll see. I don't know, but
let me tell you some
rambled on about all that, but
no, that's all right. Well, let me tell you some stuff that we did.
Hold up. Should we,
yeah, we need to mention two things.
I guess we can.
One is we need you guys to go rate and comment on Spotify, Apple Podcasts, YouTube. The more engagement, the better. So you guys give us anything you're willing to give us. If you hate it, at least tell us you hate it. If you like it, tell us you like it.
Yeah, and this is episode 10. We're going to do a giveaway. You need to drop a comment what you like about on the podcast on YouTube.
Yeah. Tell us
what you like. What are we giving away, Pat?
Let's see. We are giving away a Lixie dead blow hammer. Probably one of the nicest dead blow hammers that you can have. A Machinist Calculator Pro, which is super nice calculator for machining and trig, speeds and feeds, everything. And we're going to be giving away just some swag. We've got stickers for each of us. We've got shirts. Brad's got a ton of shirts, hats, who knows what.
Hats.
So all kinds of goodies for you guys. And we really do appreciate everything that we get from our audience here. The comments are great. They help kind of keep us going. Just in the last couple of weeks, we've received several really nice comments from some people about, our podcast is helping them in some way. They're learning from it. They're enjoying it. It's helping motivate them to become more into the trade. And that's just very lovely.
Brad got a whole letter.
Yeah, he got a whole letter. People don't even write letters anymore. Maybe they did back in your day.
I sent him a shirt and a hat.
Nice.
Yeah,
that's awesome.
One of my favorite things about it has been getting messages on Instagram and stuff about how much they enjoyed it, or even just they'll listen to the podcast and hear us talk about something, and then they'll message me and be like, "Hey, I'll talk about a problem I have," and they're like, "Oh, hey, this is how you solve that problem," or "Here's this product to help you with that." Or
if you listen to the podcast and you want to share something like that, hop on the Practical Machinist forum and share it, just so you're not just directing it at us. Other people might want to read that too.
Now, I was going to ask y'all what you had going on around your shops lately. If you had anything new going on, or exciting, or shitty, or
turning, not exciting at all.
Your least favorite thing in the whole world.
I'll be honest, man. I actually enjoyed turning to an extent.
Yeah.
I don't really mind it. It's just I don't do it enough that it's just something that I can hop into and do. It's always okay. Well, I don't remember how I did this. How do I do this?
Mm-hmm.
Yeah.
Well,
it's like
and the bad
something
thing,
I got to do more of.
Solving a riddle every time.
Right. Well, the bad thing is, it's if you ever have an extended period of time where you do that, you'll get good at it. But then if it's 6 months later, you don't do any more turning, you're kind of back to square one.
You forget it all again.
As far as anything new going around here, we're still slow. I mean, I think the whole time we've been hosting the podcast, I've been talking about how our workload is slower than it should be. Now, we're recording this on November 2nd. Those of us in the U.S. know Election Day is on the 5th. I expect that things are going to change after that, regardless of the outcome, because it always does. I don't know why, but election years for us are always slower, especially presidential election years.
It's like everybody holds their breath until after the election and then goes back to spending the money the same way they were before.
Right.
I
think
just
that's a lot of
I
it.
just started feeling a little bit of a slowdown the last couple weeks. I mean, I hear everyone say it's election year, it's going to slow down, and I've never really. I mean, I guess 2020 was the first year I was in business. Well, not the first year I was in business, but on my own during an election year. But 2020 was kind of 2020.
Yeah.
Mm-hmm. Yeah.
So I don't really remember.
So hopefully something will change there. We do have one really cool job that I'm tickled with, and I've shared it on my Instagram page a few times. We started making these bolts for these large, heavy-duty brush cutters. They're attachments for skid steers and bobcats. We're set up to make I think they bought enough material to make almost 5,000 of these bolts. And when I say bolt,
nice,
you're probably picturing a half 13 bolt from, Fastenal, but no, it is a fully machined out of 2.5-inch 1045 rolled 1.8" threads. And they're made to be, I think that the nut that gets put on them gets torqued to 1,200 foot-pounds or something like that. It's absurd. So they're not,
Is that why you're rolling threads?
Exactly. Yeah. Yeah. And I tell you what, that's interesting. That's the only time we've ever messed with thread rolling, and it's really cool.
Well, you're doing it in the lathe in process while turning.
Yeah, exactly.
When I think of thread rolling, I think of a traditional thread rolling machine where you have your dies and you actually put your bolt in there, your stud in there, it rolls it and it kicks it out.
Yeah. Yeah, it's really cool to be able to just do it in the lathe because, I mean, if we were to cut the thread, it'd probably take, 30, 40 seconds or so. It's an 1.8" 12, so it's not like it's a super coarse thread. But rolling it, it's literally 5 seconds probably. It's amazing how fast it is.
It's probably about perfect every time. And
yes, now that's the one thing about it. It's very, very finicky. You've got to get your pre-roll diameter just right. 2/1000ths on the diameter can make a huge difference in what it actually rolls to, since you're actually forming threads. And then adjusting the actual head.
Put you out of tolerance.
Oh yeah. We're checking these with go no-go gauges mainly, because thread rolling is a little funny as far as how it affects your pitch diameter, your major diameter. Essentially, what you do is more or less you turn their OD where you're going to thread down to your pitch diameter, and then when the thread roller comes in, it actually compresses it enough that it raises up the OD up to your major, usually on the lower end. But then of course it forms everything to your correct pitch diameter. But we were turning these to 1.66" initially because that's the average pitch diameter for an 1.8" 12 thread, and it wasn't working. I couldn't get it to for the go gauge to go well. And by the time I did, the no-go went too. We started turning them to 1.64", so 2/1000ths difference, and they're perfect. So it's really finicky. But once you
how long
get
do those dies last?
I don't know. Hopefully a while. I'm trying to find that out from the manufacturer because they're $1,000 for a set. So, you know, I'm hoping
Is there a chart for this for all your diameters?
Not that I could find, Brad. We had to get it from the manufacturer. They sent us a little sheet specifically for that material, that thread, of what they recommended we start at.
Okay.
So they are really helpful on that side. I'll say that. So I know, Cam, your threaded rods
last a long time.
That's what I'm hoping. Yeah, those threaded rods that you're making, I feel like it'd be a lot of investment, but maybe not if you can get by with a smaller head. Might be worth looking at.
One forms it a little bit, then the next one forms a little more, and then the last one finishes, kind of thing.
Kind of what I wonder. Yeah. Or it helps keep them spaced, 33% of the pitch apart or something.
So the threaded rods we do, we can't roll form them. We're making them out of 4140. They'll be from like, typically we'll do 832, 1032, quarter 20. I think we've done some 5/16 ones and some 3/8. Anyways, like above quarter 20, it's no problem to run them on the lathe. The problem we have is the material has to be the major diameter of the thread. You can't run it. You can't use anything smaller. That's spec'd out from the company we're making them for. They're threaded on both ends, and they need to have a certain tensile strength and everything. So they need the unthreaded part of that rod to be as big of a diameter as possible. So we can't roll form them, because if you roll form them, you have to have pitch diameter stock, which obviously is smaller than the major diameter. But the problem we have is, really these things should be ran on a Swiss, but we don't have a Swiss, so we can't do that. You'll have 832 threads, 1.25 inches long, which if you turn threads, especially, with a big length to diameter ratio on a lathe, that ain't going to go too well. By the time you get down to your finish pass on 832, it's going to be rolling up over your insert, and it's not going to go well. So the way that we've been doing them, and it works well, it's just slow and kind of a little finicky to dial in, and just kind of time consuming. We're taking a collet block, mounting it on the table in the mill, and then actually cutting it with a die in a modified die holder, in a tapping holder, and a tool holder on the mill. So we just run a tapping cycle and just X0, Z0, and then whatever Z depth you need. We threw thread pitch in there, and we're actually, we'll keep a acid brush in a container on the table with some Molly D in it, and you brush a little Molly D, or you drop your new rod in there, lock the collet block, brush a little Molly D on, hit cycle start, it'll come down, use the die to actually cut the threads, and then pop it out, pop a new one in, carry on like that. But anyway, so if anybody's got any better ideas on how to do that, message me on Instagram or something.
Can you thread whirl on a turn-in center, or is that just Swiss?
I've never done thread whirling.
I think you can.
I know they do it on Swiss. I don't know if you can do it on turn.
As long as you've got a live tool.
Because don't they tilt a little?
I'm not sure.
I don't know much about them, but I know they work great on the Swiss.
The way we used to do these was on a manual lathe with an actual like thread cutting head, and you had 3 little cutting dies that went in there, and you'd have to adjust it. It was kind of a pain to adjust, but we'd mount it in the tailstock. You set your depth, and so you throw a rod in the chuck, put a little Molly D on it, take your tailstock and push it into the leave it unlocked and push it into the rod, and then it'll grab as it's cutting the threads and pull the threading head into the part. Then once it hits the depth, it releases. You back it back out, flip a little lever on it. The first time is roughing, flip the lever. Now it's finishing. You push it, do it again, and then pull it out. And that's much more laborious than the way we're doing it now. And I think the way we're doing it now is faster anyways. So I don't really want to go back to that unless there's a good solution for doing it on a lathe, on a CNC lathe, where you don't have to just sit there and flip a lever every time, or, dick around with dialing those dies, those cutting dies, because they're a pain.
Yeah. What kind of quantity are you looking at, Cam?
Well, that's another thing. It'll be, 50, 100 rods at a time that we'll get orders for. And I mean, they're not exactly making us rich. So,
well, have you thought about trying to get a place with a Swiss machine to make like a batch of them, and then you guys just keep them on the shelf?
Well, so the problem is, it's the drawing for that part is a tabulated drawing. And so it's got a ton of different material specs, finish specs, heat treat specs, thread diameter, thread length, different lengths on both ends. So we do get a lot of repeat orders, but it's almost different every single time. So we can't necessarily, it's not like there's just 3 different part numbers. we might make 30 different part numbers of these. And
Okay.
so, and it's at a low enough quantity where I don't think most Swiss shops would want to touch it. Not that I've really tried, but
Right.
I don't know. I don't think they really would. Really what I would like to do is get like a used Swiss machine for like 20, 30 grand and just leave it set up to run these threaded rods.
Sure.
And, you can just adjust your macros for your thread diameters and lengths and all that. And then in your part length and just load up precision ground 4140 rod and in the bar feeder and just let it run and then tell it how many you want, let it spit them out. I'm assuming it's probably not that easy, but
Sure.
that's what I would like to do.
I've never messed with a Swiss lathe myself, but I've known a few people that have. Usually Swiss lathes have a sub spindle, and a lot of times it's actually independent of the main. I mean, you can actually be machining on both spindles at the same time. The tricky thing in that case would be, unless you had the tricky thing in that case is you'd have to have two die heads, I'm pretty sure, because you need one for the main, one for the sub. So, or I guess if you could single point thread them, you could.
Well, unless you have a die head that can last.
Right.
But the benefit of single point threading is I can use the same threading tool for 1032, 832.
True.
Quarter 20.
Right. Yeah, that's a good point. So,
and then we could just spit these things out. That's
yeah. That
in an ideal world, the way this would work is I would walk up to that machine, turn it on, adjust some numbers, basically say thread diameter, thread pitch, thread length on each end, and overall length and quantity. Dial in the first one and just let it shit out the rest.
You could if you haven't already, you could probably talk to Ben in the group chat. Ben Jimco.
Yeah.
And he, they have all kinds of Swiss stuff. Oh, there you go. Yeah, he does all kinds of Swiss stuff. So that'd be good. We did get back an employee that left us about 2 years ago. A young lad. He's, I don't know, nice. 2-3 years younger than I am. And he's actually been the one running the bolts. And it's amazing, man, how much you don't realize. I mean, I missed him, when he left and everything. Kept up with him a bit, text him, Instagram message him every now and then, just checking in. But it's amazing how much I realize how much I miss somebody if they come back. Because he came back the first day that I saw him, because he started on Monday and my shift, my week starts on Tuesday. And I was like, man, it makes me so happy to see you sitting over there. I missed you. So that's nice.
We got some good stuff going on. I talked about the ERP software. It's a little bit different than most of the ERP softwares I looked at. It's really, really, really easy to use. Whenever I'm looking at stuff like this, like I don't want to implement anything new that's going to drastically slow us down, have a really steep learning curve. I don't want to implement a bunch of bullshit that seems like it doesn't have any purpose. I don't want to add in bureaucracy to everything. So I'm keeping that in mind whenever we're going through stuff. And so I found this ERP system, and it's really just simple, intuitive, has a lot of features. I don't really know what else to say about it because I haven't gotten too far into it. I'm like a week into messing with it. But anyway, I think it's going to be really good. I think it's going to be really helpful and really help us track things from start to finish. And we can retain, drawing solid models, processes, the actual routing of the part, all those things within the part. And it's clear and obvious how everything is supposed to happen with this part. But anyways, all that will be retained. So when you get a repeat job, you just pull up the part number, say this quantity, it figures out the price for you, or you can put in your price and then boom, you're on your way. So we're doing that. I just signed the stuff the other day to start a inspection software for auto bubbling and basically spitting out inspection reports for you.
Do you guys do them inspection reports on everything, or is it customer job specific?
This is all just for us. We don't
Just for
have
you.
customers requesting inspection reports from us.
Okay.
So this is all for internal things. And I'm trying to figure out how to make sure this doesn't become like a huge time suck. Because what I don't want to have happen is, guys end up spending hours just trying to inspect their first part or doing in-process inspections, to where it really decreases productivity. I'm okay losing a little bit of productivity to make sure that we're making good parts the first time, because in the end, that's going to save you time if you're not having to remake parts or modify parts to make them work. So I'm okay losing some productivity there, but I don't want it to turn into just a huge, time suck. So I'm trying to figure out exactly how I'm going to make that work efficiently, but I think I'll be able to make it easy. But the nice thing about that software is it's, I don't want to say fully automated, because I don't think there's any software out there that can look at any print and pick up what type of dimension, what the actual dimension is, what the tolerance is for the dimension, like all those different things, and put it into a spreadsheet or whatever format for you. But I mean, it's pretty damn good. Like, if there is anything that it misses, you can go back and manually select it, and it'll pick it up. And if it doesn't, you can just manually do that, that dimension. Like, you can manually input all the different parameters for it pretty easily. And you can even designate, like, I want you to use these inspection tools. So, like, say I want you to use micrometers for this, or I want you to use the digital height gauge for this. So you can designate those things, and then you can also separate things out by operation. So, after your first operation, I can have it where it's only showing you the dimensions that you need to check on your first operation. Then second op, you can do the same. So the guys aren't like trying to decode the print and be like, okay, so I can't measure that yet, but I can measure this. And that just adds a bunch of time. So it's like, you just go down the list of what you can see and inspect those things, and then cool. That
would be nice, because I've done some inspection reports where it's you're trying to figure out what features you've done on that first stop and check them.
Yeah.
Where if you have it separated, that'd be nice. It'd help with efficiency too.
Exactly. I basically wanted to make it where you don't have to think about anything. That's my goal with everything. Like, I don't need to think about how this needs to be done and pre-plan, or stop and just, look at this for print for 10 minutes and figure out what the hell's happening. But I want it to just be simple, self-explanatory, and easy for pretty much anything around the shop. But so anyways, there's the inspection software. And then I guess the last new thing is we're getting a new machine delivered on, I think, the 13th this next week. So what's today? Saturday. So yeah, this next week is our last full week of work before that machine shows up. And so we got to pump out everything we can this week. And then next week, it's going to be, we're not just removing that old machine and putting a new one in. We're also moving 2 other machines around. So it's going to be, and we pretty much have to move everything out of the shop, or at least move it all over to one corner so the riggers can have room to work in there. So it's pretty much going to just stop production for the majority of the week. So it'll be pulling out coolant tanks, moving equipment, moving just stuff, cleaning coolant tanks, all of that. So it's going to be a fun time. I don't mind it. I like getting dirty and cleaning coolant tanks, honestly.
I got quite a bit of lathe stuff I got to quote, so I just got to figure out how I'm going to do it, if it's worth messing around. I got some parts that they exceed my capability, but I think I can fandangle them in, and I'm just trying to decide if it's worth it.
Sounds like half the work you do.
Yeah, well, there's some parts, they're probably, I think they're 28 inches long, 3-inch diameter. They got some bores on both sides. And they call out 6061 tube. So the diameter's there, the ID's there, just the 2 outsides got to be bored. I think it's 5 thou tolerance, nothing crazy, but I think I could squeeze it in my horizontal and spin it and bore each side. I don't know. I got to see if it's worth it.
Yeah. I bet you could do that.
Yeah, I'll probably end up doing it just because. See if I can crash the horizontal, hit a wall or something.
How are you gonna hold it?
Probably soft jaws. I'll just bore 3 inches through.
Yeah.
Clamp it in between 2 and then
spin
it. We'll see. Pick up each side. I think there's 3 variations, quantity 1 of each. So
yeah. What's the length?
One of them's 28. I think it's 28, 26, and 24.
What's the tolerance?
Just on the bores, it's just boring in, I think, 3 inches. I think it's a -5 thou.
What's the length tolerance?
I think it's 20.
Okay.
It's a 2-place.
That's not bad.
I bet you could get there with a tape measure.
Yeah.
Do you have calipers, like some big verniers or anything?
No, not that big.
No.
Man, come on.
I'd probably just, I don't know.
I know what you can do. Like after your first op, take it out, put it in your mill, and just check it from end to end and get your measurement using basically the DRO on the mill.
Yep, I've done that a few times.
Then put it back in, say, all right, I need to take 40 thousandths off.
Yep. I could probably even just throw it in my vertical and just cut the ends.
Oh, yeah. There you go.
Oh, wow, yeah.
Easy peasy. Use the same jaws.
We'll
there
see.
You go. Problem solved.
And then there's some other lathe parts there. I think there's one that's 6 inches, 8 inches, and 10, but it's got to bore. It's got to bore all the way through. I don't know if I got the length to get it in my machine, my SL20, and bore it, unless I try to flip it. But that's another one where I think it's a -3 tolerance to the whole bore.
Yeah.
So I'll probably just pass on them ones.
You crash into your tailstock a few more times, it just won't be there anymore, and you can get the length out of it.
Right. I got a quick question about turning.
Okay.
Yeah.
What's the best way to position your jaws? So my jaw, it's got the serrations. So every time I adjust it, I got to do one, do the other. How do you center them?
Like, how do you know if you have them all equally?
Yeah.
I usually will just take a scale and measure from the back of the jaw to the outside of the chuck.
Yep.
Or like the outside of the little serrations.
Yep.
You can
That's
count
what
the
I've been doing
teeth
too, but I don't know if there was a faster trick.
Mm-hmm.
I count the teeth sometimes, and then it's like you get up to the actual jaw, and you're like, okay, do I count that one because I can see it? And then you go to the next one, and you don't count it, and then you count the next one.
That's why I started measuring. I used to always count, and then I lose track halfway counting through. I'd be like 12, 13, 15. Wait, fuck.
Did I count that quarter one or
right? Yeah. No, I always measure. Yeah. You know what I do too? All right, so I got to remember how I did this. I'll figure it out and let you know. So I made a chart like for our big lathe. It's got a 24-inch chuck with big ass jaws on it. So it sucks to put them all on there, realize you don't have the right diameter, then have to move them out 1 or 2 or whatever, guess. So I actually made a chart. I used Excel. There's a certain formula you can use. And I figured out what this, I think it's, I don't remember what the spacing is. Might be 3 millimeter on that one or some shit because they're big serrations. Anyways, I've got a whole chart that shows you, like at 20 inches of diameter, this is how far it needs to be from the back of the jaw to the outside of the chuck.
Okay.
Or at 19, 18 and a quarter, or 18 and 5/8. Like it's just goes down the list every, I think, 1/8 of an inch. So whatever your stock size is, you just refer to that chart and say, okay, so I need to be 1 1/4 inches in from the outside. And then you get it on there with a scale, 1 1/4 inches, boom, push it in, tighten your bolts down, and you're on your way.
What about clamping pressure as far as, so if you're clamping on a 5.5-inch diameter stock and them close, what do you want them to close at?
What do you mean?
As far as, so if I...
Like travel distance?
Yeah.
I usually try to get it mid-range.
Mid?
Yeah.
Yeah, so like get it to clamp about middle of the travel.
Yep. Okay.
And I think that might be how I set it up. I don't remember exactly how I did it. It's been a while since I created that chart, but
when I bore
either
jaws,
way, it'll get you where you only got to adjust one time after putting them on.
When I bore jaws, of course, I use a boring ring. I usually bore them kind of like in the maybe 25% closed. That way, if I need to, like if something happens and I need to recut them, I don't have to actually move them in. I can just, put the boring ring back on, swing it in a little bit so it clamps tighter, and then just skim the jaws back. Yeah, it's best not to have it clamp at the very bottom either, because there's a very fine line between it clamping and it really just sort of holding the part in there, and then it comes loose. So,
yep. Yeah, and if you're running high RPM too, now I haven't really tested it, but I believe it's true. If you're running higher RPM, the centrifugal force of your jaw, the weight of your jaws, is actually going to apply. You're basically going to lose chuck pressure on your part as you gain RPM. Because you're using hydraulic pressure to keep them forced in. They're going to start pushing against that hydraulic pressure and want to open up. So I've always heard you have less pressure on the part whenever you're at a higher RPM. So we'll turn the chuck pressure up if you're going to be running like 1500 RPM or something, and then make for sure that you're within the middle of the travel.
Yep, that makes sense.
Yeah.
What pressure?
I'm gonna get this down one of these days, and I'm gonna become a turning pro.
There you go, man.
Back in the day, I ran an engine lathe for probably 10 years, but it's been 10 years since I ran one.
Wow. What pressure do you usually just like general purpose do stuff with, Cam? In general,
I don't remember on the little lathe. I don't ever really mess with the chuck pressure. On the big lathe, I mean, we'll turn it up to what is it? I don't remember the PSI. I don't even know what metric it's using. There's a chart on there on the back of the door. It says 21.5 is the max, whatever that might be. It's not PSI. It might be KPSI. But anyways, 21.5 is the max. So I kind of I'll just turn it down from there. If it's something that I know is going to, like a big plate or something that I know is going to want to bow out in the middle. Or if it's something heavy and I'm going to be aggressive with it, I'll just turn it all the way up to the max.
Gotcha.
I should probably know what that number is, but I know 21.5 for that 24-inch chuck is the max on whatever that gauge is.
Okay. That sounds like maybe bar instead of PSI, because on our lathes, it's like from 100 to 350 or so PSI. And I'm usually 300 on most things. Like if I've got solid bar stock, or if it's a solid part, like a slug part, I'm usually around 300 PSI or so. I'll drop that down if it's tubing or plastic or something. So,
or if you're going to bore out the middle of it or something.
Mine's at 250, and that's where it's set, so I just left it.
Yeah, that works for most things. All right, boys. Sweet.
Guess we'll wrap it up.
Remember to hop on YouTube for the giveaway. Comment on YouTube. That's your entry.
You have to tell us what you liked. Or what you liked about the podcast.
Or something.
Yep. Don't forget to rate on Spotify, Apple, and YouTube, or really wherever you listen. But we could really use the engagement. We appreciate it.
Yeah, means a lot.
Pat, what are we giving away?
A Lixie dead blow hammer, a Machinist Calculator Pro, and some swag, stickers, hats, shirts.
Awesome. Well, there you go.
See y'all later.
Good spot to wrap it up.
All right.
See you later. Thanks for listening.